Hi everybody, I hope you've been enjoying your break so far. This is the first of two videos for you to watch over break. It's on particle motions and integrals. This one is part 1, and number 38 will be particle motions and integrals part 2. So in your notebooks, you're going to want to go to the next blank spot and take these notes down. This video is mainly 2 examples. The next one will be some new information we haven't really done yet. So for your first problem, consider a spider that's crawling left and right on an x-axis. He's going back and forth. Here's information about his moves. For the first 3 seconds, up to but not including the 3rd second, he's going 1.5 feet per second. That is to the right. Then starting at 3 seconds and to infinity, he's going negative 3 feet per second. Remember, a negative velocity means he's going left. S of 0 equals 4 feet on the x-axis. Remember, S means position. It can be x, but usually it's S. So that's position. He starts at 4 feet on the x-axis. What I want you to do is make a table with time, velocity. This is position. It's not speed. This is speed right here. Fill it out for the first 7 seconds, and then what I want you to do is sketch the graphs of velocity and speed for the first 7 seconds. So pause the video now and do that, and then you can come back and check your answers. Okay, here are the answers, so check your work. There's a couple things I want to clarify here. First of all, when you're filling this out, velocity isn't too bad to fill out. Notice at 3 seconds, this equal bar means he's going negative 3 feet per second right here, not 1.5 anymore. These are all negative. Also notice that speed and velocity are basically the same thing. It's just that speed is the absolute value of velocity, so it's the same numbers, but just positive. Position, there's one number I want to clarify here, and it's this number right here that I highlighted. Notice these first 4 numbers go up by 1.5, and then starting at 8.5, they decrease by 3 because he's going left 3 feet per second then. Some of you might be wondering, why isn't this 8.5 a 4? Because at 3 seconds, he's going negative 3 feet per second, so you should be subtracting 3 from here. The thing is, if you think about it like this, hold on. All right, he starts at 4 on the x-axis at time equals 0. From 0 to 1 second, so basically here, it's 1.5 feet per second. So now at 1 second, he's at 5.5. From 1 to 2 seconds, he's still going 1.5, so now he's at 7. From 2 up to 3 seconds, not including 3, like 2.999 seconds, he's still going 1.5 meters per second to the right. So that puts him at 8.5. As soon as, whoa, what am I doing here? As soon as the timer hits 3 seconds, then he starts going to the left, 3 feet per second. So then at 4 seconds, he's back at 5.5, and then 3, so on and so on, like that. Notice the similarity between velocity and speed graphs. It's just that velocity has negatives. Speed is basically the same thing as velocity. It's just you take anything under the x-axis and flip it over the x-axis so it's in the positive portion. So make sure you're all set with that. The next page here, I have questions based on these graphs and this table and this information. So this is an extension of the problem before. For each of these 7 quick questions, I want you to give a number, so it'll equal a number, and then I want you to state or explain in words what it means in this context: movement, left and right, speed, displacement, all that stuff. So pause the video and take some time and fill this out, and then we'll go over the answers together. Make sure you're actually pausing the video. All right. So check your answers here. So hopefully you've had some time to think about these and you got most of these. Okay. If I have an integral of velocity, what you need to remember is that the integral of velocity is displacement. It doesn't take into consideration that he might have gone left and right and backtracked. This is just the difference between ending and starting position. And that will be negative 7.5 feet because he started at 4 feet and then he ends up at negative 3.5 feet. So that would definitely be negative 7.5. Now, if you do the integral of the absolute value of v of t, that now means total distance traveled, because the integral of velocity, remember, is speed. So if you do the integral of speed, this is the total distance traveled. It's a very big difference. It's kind of like when you're driving in a car and you see the odometer. It keeps ticking and ticking, whether you're going forwards or backwards. It doesn't matter if you're going front, back, left, right, whatever. It keeps ticking and ticking. That's similar to this. This one is 16.5 feet because if you look at this graph, where am I? Here. He starts at 4, then he goes right to 8.5, then he goes left to negative 3.5. 4 to 8.5 is 4.5. And then 8.5 to negative 3.5 is a negative 12, but in general, it's just 12 feet moved. And you add those together and you get 16.5. Another way of looking at it is if you take the area under the curve, good old area under the curve here, the integral of speed, which is basically what this says right here, the integral of speed is 4, and then this area is 12. Nope, this is 4.5, sorry. And that's 12. And when you add those together, you get 16.5. So you can think of it numerically and also graphically. Remember, seconds times feet per second is just feet. Okay, moving on. This one we haven't really talked about yet, and we're going to focus more on it this week in class. So it's very important that in this video and the next video you understand what it is. I'm doing the absolute value after. So first I do the integral of velocity, which gives me displacement. Then I do the absolute value. So this is the absolute value of displacement. Notice this number and this number are almost the same. It's just that this is positive because it's absolute value. This is how far the spider is from his starting position, but it doesn't tell you left or right movement at the end. So here, the fact that it was negative meant that he was left of his starting position. And that's true because negative 3.5 is left of 4. Here, the answer is just 7.5. So that means the spider is 7.5 feet from where it started, but we don't know if it's left or right. S of 7, that's his position at 7 seconds. So if you look at the graph here, actually, no, it won't be on the graph. But if we look at the table, the position at 7 seconds is negative 3.5. Okay, this one asks for the speed at time equals 7. Well, that's just the absolute value of velocity, so that's 3 feet per second. That's how fast he's going at 7 seconds. No direction here. If I ask for v of t, that is asking how fast and in what direction he's going at 7 seconds. So at the 7th second, he's going negative 3 feet per second. So to the left, 3 feet per second. This right here, you have to recognize this as just asking for speed at 7.5, which is the same exact thing as number 5. So these are the same, they're just written slightly different. So same answer, again, speed, how fast he's going without direction. So make sure you have this filled out here and you listen to anything again if you didn't quite understand it. And the next video is an extension of particle motion and integrals.